Besides a mammoth revelation made by way of approach state-of-the-art, the James Webb Space Telescope, town lighting gadgets in space noticed 7 trillion miles from Earth. This remarkable finding has lighted interest inside the possibility cutting-edge extraterrestrial existence. The telescope zeroed in on Proxima Centauri b, the nearest exoplanet to Earth, uncovering eminent, improbable lights transmitting from it. What can be the reason for those town lighting on Proxima Centauri b? Should this later on-screen the present-day existence beyond our solar gadgets? Be a piece of us as we plunge into how the James Webb Space Telescope has discovered these top-notch things in space for an extended time. Outline specialists and every person have speculated approximately life beyond our close planetary neighborhood, suggesting lifestyles have been restlessly expected. Certainly, the clinical affiliation have become hanging over area's present-day solidarity for a while. Living elements had been seen by way of the James Webb Space Telescope whilst concentrating on the place and sending critical records lower back to Earth. The James Webb Space Telescope implied difficult to disregard town lights shining from the exoplanet Proxima Centauri b. Those lighting devices have been, as it should be as their call for warned, lighting fixtures like the ones illuminating a town. The possibility present-day an outcast metropolis gift on the exceptional call has left specialists burdened and befuddled. As it appears to be the approach today's lifestyles, they have all been looking forward to that this is seemingly actual. As considered one of believes it pushed ultramodern that there are practical dwelling animals constructing progress new to what humans type out in space. Moreover, we are clearly going over it, learning the city lighting mechanical assemblies arranged 7 trillion miles from Earth. NASA makers cannot face up to the urge to can't help thinking about how extensive those lighting fixtures were found in district. David Kipping, a cosmologist from Columbia University, portrays the Proxima Centauri b exoplanet, wherein the town lighting fixtures establishments had been organized as captivating. He communicated so modern-day the reality the movie star structure closest to us has changed for patterns that are not like different planets. The ordinary rocky planets are acknowledged to soak up sunlight hours and transmit infrared radiation, however not so for this exoplanet, as its infrared nature is especially first magnificence from that modern-day its host celeb named Proxima Centauri. This requires an immense observational eye through the James Webb Space Telescope, JWST, and the telescope turned out to be beneficial as the genuine contraption for the undertaking. The JWST can no question recognize infrared frequencies, the instant electricity herbal for Proxima b, which can be a central element in uncovering the unfold-out special bits modern-day understanding its ongoing scenario. This will be carried out thanks to the prevailing time modern-day infrared imaging abilities advanced via the JWST. Specialists want to apply the telescope to discover the regular portions modern-day this planet at air stages. They furthermore plan to use the Internet telescope to check out the possibilities cutting-edge existence in this exoplanet. The James Webb Space Telescope has an infrared mindfulness that is ready to take apart what occurs on Proxima Centauri b's in perspective. Getting the smallest touchy outpourings in the unfathomable haziness is ultramodern very challenging for district telescopes but not for the JWST, as it may view as even the littlest sensitive releases from area. It is an outstanding contraption to test assuming to be just the research about city lighting on Proxima Centauri b. Today's view are considerable or not only one-out trendy atypical made mild inside the universe can be perceived by using the telescope as long because it falls interior a recurrence band that is state-of-the-art more modest than the TIE. Proxima b has an empowering courting amongst its heavenly substances and floor conditions. Modern day the exoplanet consolidates exclusive solar chargers that address the impacting solar electricity released through the movie star, whilst its supernatural region mirrors approaching mild bars inside the C program language period. Precisely whilst Proxima b completes its circle around its host star Proxima Centauri, it evaluations always cycles ultramodern like what we've on the Earth, with the daytime having excessive sun significance and the 12 p.m. experiencing coolness. The planet is concept to have temperature varieties coordinated via its form. For instance, assuming there may be no environment on Proxima b, the differentiation among its day and 12 p.m. cycles can be gigantic and some distance separated assuming there is no controlling effect contemporary ecological gases. What is extra oceans the temperature modern day the daypoint cutting edge view can be sizzling warm like a faint aspect, and the 12 p.m. will plunge into the cool fogginess. The diploma modern temperature version is a prepared situation for cosmologists to determine a greater significant ability contemporary Proxima Centauri's shape. Having an unmatched infrared imaging capability, the JWST can to make sure note the planet's warm outpourings to offer sensible studies about its ordinary homes. Simply, the circle modern day the James Webb Space Telescope throughout the Earth strains up with Proxima B's orbital time period, giving a complete point of view on its 24-hour cycles within 11.2 Earth days. Assuming it for sure has an environment, the following step can be to determine its ordinary resourceful capability to pick out if it can uphold life. A few excellent signs in seeing whether there's presence are the presence modern-day gases like oxygen, water vapor, and methane. Assuming those parts are tracked down at the global, it indicates that it remains contemporary feasible conditions for lifestyles. The mission contemporary actually spotting this requires examiners to be fussy as they collect and study light bars that undergo the planet's ecological components. This is a really difficult mission. Anyhow, the JWST has implausible capacities for depicting planetary conditions. It has an essential objective. The telescope has been programmed to fine gander on the assortments in water vapor, carbon dioxide, and methane mindfulness. Even as it comes to spotting in addition advanced oxygen, that's a vital signal modern day something happening a ways beneath the JWST is restricted around there, albeit the telescope all things considered has key inspirations to search for changed parts in the average like ozone, which gives a first-rate degree latest importance within the air. The truth that the James Webb Space Telescope doesn't have general capacities and can't peer at most probably the closest possible universes to Earth leading in careful air exam. Area professionals are currently leaning state-of-the-art floor-generally based totally observatories like the notably huge telescope ELT. The ELT is a telescope that has been deliberate to begin operating in 2028, and its miles conclusively spot to look extra enormous into the barometrical affiliation cutting-edge far-flung exoplanets. It'll provide information on those planets to give total and clean pieces present-day records into their diploma ultramodern reasonableness. NASA scientists and modern day are energetically trying to find the affiliation cutting-edge future space telescopes like those. Until that element, but the James Webb Space Telescope remains an important device in our trip to find the insider statistics contemporary far modern exoplanets. During its advancing limits, the Internet Telescope has the capability to offer beast pieces modern-day information in an effort to trade how we interpret exoplanetary makes a speciality of now and in the future. Experts have an objective for Destiny area telescopes, and that is to reduce how a lot wonderful delicate coming from a planet's host me's star. So stargazers can all the nearly positive see the lighting considered from an exoplanet itself. They mean to endeavor this the use of inner sun conceals or big outdoor sun-powered sun hides shaped like an umbrella like the usage of your hand to close out mild discharges to allow you to see a factor clear. Reducing the top-notch splendor coming from the host virtuoso will better position Destiny telescopes to zero in on faint impressions today's sensitive coming from exoplanets. Thinking about best examination brand new its natural framework and the possibilities supporting approaches ultramodern lifestyles. Doing this is going with its very own demanding situations but researchers need to recognize gases contained existence and those from land cycles like volcanic facet hobby. Area specialists are not leaving greedy the trait's latest exoplanets so they are better organized to at outcomes modern day something going on an extra huge level and don't forget them from thrilling signs. The JWST represents all the while an explosive open door. A wonderful tale has emerged, genuinely that a pair outcasts are a point present-day reality something especially awesome within the stars. Essentially believing that individuals will tune down them to provide a response to this inquiry. American space specialists Jill Tarter moreover Thomas Pearson started a project implied as the excursion for extraterrestrial know-how. Study in 1984 taken into consideration the CI affiliation. It is a beneficent affiliation meaning to channel through grandiosines to honestly get radio transmissions from space. The point at the back of spending critical time in radio transmissions is an end result of their ability to tour substantial stages without getting dissipated or held like numerous cutting-edge radiation. By virtue latest this photo, radio transmissions are certain to be perceived through the 42 radio telescopes that make up the Allen Telescope cluster organized inside the lower district's contemporary California. Notwithstanding the truth that at this factor the SEI affiliation has now not permanently set up symptoms today's radio transmissions made by way of extraterrestrial lifestyles. There have now not been such indicators for extra than 30 years. The manner that they will make Jill Tarter moved have a fantastic outcome as they intend brand new the gadgets modern the 21st century to get the rate the chase in a manner that could sound ordinary to Jill. I need that you may give her a commission for all of the bits of information that you have set for her. Jill Tarter and Thomas Pearson embarked on a journey known as the Search for Extraterrestrial Intelligence, SETI, in 1984, aiming to detect radio transmissions from space. Their focus on radio waves stems from their ability to travel vast distances without dispersing or being absorbed like other forms of radiation. This makes radio transmissions a promising candidate for detection by the 42 radio telescopes comprising the Allen Telescope Array located in the hills of California. However, despite the efforts of SETI and other initiatives, there has been no conclusive evidence of radio transmissions from extraterrestrial civilizations for over 3 decades. The absence of such signals prompts reflection on the challenges and the potential implications for humanity's understanding of its place in the universe. The quest for extraterrestrial intelligence continues to evolve with advancements in technology and the establishment of new observatories. Future space telescopes, including the James Webb Space Telescope, JWST, are poised to contribute significantly to this search. Their enhanced capabilities in infrared imaging and spectral analysis promise to deepen our understanding of exoplanetary atmospheres and potentially identify signatures of life-supporting conditions. Moreover, the JWST's ability to detect faint infrared emissions from distant planets opens new avenues for studying planetary systems beyond our solar system. By scrutinizing the composition of exoplanetary atmospheres, scientists hope to uncover clues about habitability and the presence of life forms, thus pushing the boundaries of astrobiology and planetary science. In conclusion, while the search for extraterrestrial intelligence remains an ongoing scientific endeavor with challenges and uncertainties, it represents a profound exploration of humanity's curiosity and quest for understanding. The discoveries made possible by instruments like the James Webb Space Telescope offer tantalizing prospects for unraveling the mysteries of distant worlds and potentially finding answers to the age-old question: are we alone in the universe? The exploration of extraterrestrial intelligence, ETI, spans across disciplines, from astronomy and astrophysics to astrobiology and space technology. At its core lies the fundamental question: are we alone in the universe? This question, deeply ingrained in human curiosity and existential ponderings, has driven scientific inquiry for centuries and continues to inspire innovative approaches and advancements in our understanding of the cosmos. The quest for extraterrestrial intelligence can be traced back to early astronomers who speculated about the possibility of life beyond Earth. As telescopes became more sophisticated and our knowledge of the universe expanded, so too did our ability to search for signs of life elsewhere. The development of radio astronomy in the mid-20th century marked a significant milestone, offering a new tool for scanning the skies for potential signals from distant civilizations. One of the pioneering efforts in the search for extraterrestrial intelligence is the SETI project, founded by scientists like Jill Tarter and Thomas Pearson in 1984. SETI employs radio telescopes to listen for narrow-bandwidth radio signals from space that could indicate intelligent extraterrestrial life. The rationale behind using radio waves lies in their ability to traverse vast distances without significant degradation, making them a plausible medium for interstellar communication. Over the decades, SETI has expanded its scope and methodology, utilizing arrays of radio telescopes and sophisticated signal processing algorithms to sift through the cosmic noise for potential signals of extraterrestrial origin. Despite numerous targeted searches and promising candidate signals, no definitive evidence of extraterrestrial intelligence has been conclusively detected. The absence of detected signals raises intriguing questions about the nature of intelligent life in the universe. Are technologically advanced civilizations rare, or is our methodology for detecting them fundamentally flawed? These uncertainties underscore the complexity and challenges inherent in the search for extraterrestrial intelligence, urging scientists to continually refine their approaches and technologies. In parallel with radio-based searches, the discovery of exoplanets, planets orbiting stars outside our solar system, has revolutionized our understanding of planetary systems and their potential for harboring life. The Kepler Space Telescope, launched in 2009, played a pivotal role in this revolution by detecting thousands of exoplanets through the transit method, which observes the slight dimming of a star as a planet passes in front of it. Among the thousands of exoplanets discovered, a subset lies within their star's habitable zone, the region where conditions may allow liquid water to exist on the planet's surface. Liquid water is widely regarded as a crucial prerequisite for life as we know it, prompting focused efforts to characterize the atmospheres of these potentially habitable exoplanets. Enter the James Webb Space Telescope, JWST, successor to the Hubble Space Telescope and scheduled for launch in 2021, updated timeframe. The JWST represents a quantum leap in observational capabilities, particularly in infrared astronomy. Its large mirror and advanced instrumentation will enable astronomers to study the atmospheres of exoplanets in unprecedented detail. The JWST's infrared sensitivity is crucial for studying exoplanetary atmospheres because it allows scientists to detect subtle spectral signatures indicative of key molecules like water vapor, carbon dioxide, methane, and potentially even biomarkers such as oxygen and ozone. By analyzing these signatures, scientists hope to assess the habitability of exoplanets and, perhaps, detect signs of biological activity. The search for extraterrestrial intelligence intersects with the broader field of astrobiology, which seeks to understand the potential for life beyond Earth. Astrobiology encompasses studies of extreme environments on Earth, analogs for extraterrestrial habitats, and the biochemical processes that could sustain life in diverse conditions. The discovery of extremophiles, organisms thriving in extreme environments such as deep-sea hydrothermal vents and acidic lakes, has expanded our conception of where life can exist. Astrobiologists draw upon insights from geology, chemistry, biology, and planetary science to explore the conditions necessary for life's origin, evolution, and persistence. The study of exoplanetary atmospheres is a critical frontier in astrobiology, offering direct observational opportunities to probe the conditions on distant worlds and assess their potential for hosting life. In addition to the JWST, future space missions like NASA's LUVOIR, Large UV/Optical/IR Surveyor, and HABEX, Habitable Exoplanet Observatory, are proposed concepts designed to advance our understanding of exoplanetary systems and search for signs of life. LUVOIR, for instance, would possess capabilities far surpassing those of current telescopes, enabling detailed spectroscopic analysis of exoplanetary atmospheres and direct imaging of distant worlds. The technological advancements driving the search for extraterrestrial intelligence extend beyond telescopes and spacecraft. Machine learning algorithms and artificial intelligence are increasingly employed to analyze vast datasets generated by astronomical observations, aiding in the identification of subtle signals amidst noise and expanding the scope of scientific inquiry. Moreover, international collaborations and partnerships between space agencies, research institutions, and private industry are essential for advancing the frontier of astrobiology and extraterrestrial intelligence. These collaborations leverage diverse expertise and resources to tackle complex scientific challenges, share data and insights, and foster innovation in space exploration. As humanity continues to explore the cosmos and deepen its understanding of planetary systems and potential habitats for life, ethical considerations also come to the fore. The implications of discovering extraterrestrial intelligence or lack thereof could profoundly impact our worldview, societal values, and approaches to planetary stewardship. From philosophical reflections on humanity's place in the universe to practical considerations of interstellar communication protocols, the search for extraterrestrial intelligence invites interdisciplinary dialogue and contemplation. It challenges us to confront our assumptions about life, intelligence, and the vastness of space while inspiring wonder and curiosity about the possibilities awaiting discovery.